So let's look at 323. What is the optimal amount application of systems of inequalities? Okay, so I posted this in the classroom so that I was hoping you would read it ahead of time because it's kind of wordy. And we're going to write down the inequalities for this and use our optimization linear programming skills to solve this. Okay, so it's kind of a fun problem. The mini monster battle, let's read it here, and hopefully you've already read it. If not, here it goes. The ultimate mini monster battle is set with mini monsters and their owners arriving from around the globe for the largest tournament ever. The organizers of the event have been working hard to make sure everything runs smoothly. Certain constraints have affected the organization of the event. Here are our constraints and things, and that we have to come up with our equations because they're never going to give you the equations or the inequalities. You have to come up with them yourself. Okay, currently the arena cannot hold any more than 50 mini monsters at a time. And the planners think the tournament will be too dull if fewer than 20 are in the arena at the same time. Okay, so it can hold only 50, but we want more than 20 or else it'll be boring. So between 20 and 50. And let's try and see what our variables are going to be. Remember in that video that the guy said, he said, hey, look at the last question. That always tells you like what your variables are going to usually. What is the optimal number of yellow monsters, mini monsters, Y, and green mini monsters, X, that should be at the arena event? Okay, so X, they're defining our variables. So there, X is going to be the number of green mini monsters, Y is going to be the number of yellow mini monsters. So I'm actually going to go to the next slide where I have more room to write, and we're going to write that down. So let me get my pen here. You can write this down for 3-99. So X is going to equal the number of, is it green mini monsters? Green mini monsters. And make sure I have enough room to write all this. Y is going to be equal to the number of yellow, Y for yellow, yellow mini monsters. Okay, so that's X and that's Y. Let's go on. So we know that it can't be greater than 50, right? So we're going to have something is less than or equal to 50 is one of our equations. And then we know, but we want there to be more than 20. So we're going to have something greater than or equal to 20 because we read that part here and here. The arena is quite small. It only has 396 square feet of space. So if it only has 396 square feet of space, that means we're going to have an inequality that is less than or equal to 396 also. And we'll fill in this part on the left after we read some more. The first event will be a battle between yellow mini monsters and green mini monsters, with the number of green mini monsters being at least a third of the number of the yellow mini monsters. So the number of green mini monsters, which is X, so X is going to be at least, so it's going to be greater than or equal to 1/3 of the other monsters. So that is one inequality that we have there. X has to be greater than or equal to 1/3 Y. Okay, next. Where am I at? 4 yellow mini monsters have already signed up and are ready to compete. So we're going to have at least 4 or more yellow mini monsters. So the yellow is going to be greater than or equal to 4. All right, that's either going to be a horizontal line. It's going to be above the x-axis. Okay. Each green mini monster battles best when it is 6 square feet, when it has 6 square feet in which to move around and has easy access to 7.5 gallons of water. The yellow mini monsters need more room, 10 square feet of space, but use only 5 gallons of water during each battle. Okay, So since one of these was space, right? This one was like space. And then this was like the number of mini monsters, number of, I'll put MM for mini monsters. And this is also the number of mini monsters. Has to be greater than 20, less than 50. But this is the space. So since this is a space, we want like an X, something X plus something Y is less than or equal to 396. Okay. So the X is going to be the green, how much space the green mini monsters need. Well, the green mini monsters need, where are they? 6. Do they need 6? Let's see. Yeah, each green mini monster needs 6 square feet of space. So that's going to be 6x for each green mini monster, right? 6x. But the other monsters need more space. I believe they need 10 square feet of space, right? So they need 10. So we're going to put plus 10y is less than or equal to total space 396. Okay. Next, we need a water equation because they gave us space and they gave us water. So each yellow mini monster needs, I think, 6 gallons. Yeah, it was 6 gallons, 6x, so 6 gallons per green mini monster. And the other one needed 7.5 gallons. The other monsters need 7.5y. And it has to be less than or equal to how much water is in the thing and in the arena. And it says currently there is a 350 gallon water tank ready to be tapped for the tournament. So we have less than or equal to 350 gallons of water. Okay, so far these are our equations. Next question. The planners suspect that each green mini monster participating will result in 12 ticket sales, while each yellow monster will result in 10 ticket sales. So now we have ticket sales, and this has nothing to do with space or water or the number of mini monsters. So that tells me this is going to be our objective function, right? We haven't come up with that yet. Usually I put P or C because it's profit or cost, but in this case it's number of tickets. So I'm going to put T equals, and so there's going to be 12 tickets for each of the yellow monsters. So that's 12y, right? And 10, wait, hold on. Oh, sorry, green mini monsters are 12. So 12x, and then there will be 10 ticket sales for each yellow monster. So 10y. So that is our objective function that we're going to plug in our points to, right? So now we need to we got all our constraints. These are all our constraints. Now we need to graph them, right? And we're going to graph 1 line, 2 lines, 3 lines, 4 lines, 5 lines, and we're going to come up with a feasible region, right? And then we're going to have like 1, 2, 3, 4, 5 points that we need to plug in to this objective function to optimize or find our maximum, right? If we want to optimize, we want to find the maximum of monsters that we can have in the ring. Okay, so that is our goal now. Well, we can definitely graph all these by hand. We could do that. We would make them into y equals mx plus b, like y is greater than mx plus b, right? So I would solve this for y, I would solve this for y, I would solve this for y, and do that. But our book has done that for us. If you go to the book, you can go to the, I'm gonna have to erase this writing too, so sorry, but I gotta erase it. Question?
Is there anything to the left of the constraints of the number of mini monsters? You have the less than or equal to 50. Is there anything on the left of that inequality?
Oh, yes, thank you. I forgot to write that down. Since the number of monsters, thank you, Jack, it has to be less than or equal to 50. The total number of monsters has to be less than or equal to 50. So it has to be X plus Y is less than or equal to 50. But we want the number to be greater than 20. So the number of X and Y monsters, X plus Y, is greater than 20. So yeah, please write that down. Thank you, Jack, for reminding me to do that before I erased everything. I really appreciate that. So yes, this is the total number of monsters, right? X plus Y is your total number of monsters. So
That
x plus
wasn't
y,
me.
sorry?
That wasn't me.
Oh, that wasn't you? Oh, who was that?
That was me.
Who, oh, Ari?
Yeah.
Okay, thank you, Ari.
Yeah.
You guys kind of sound alike. Sometimes it doesn't tell me who's talking, so thank you. All right, so these are our 5 functions that we need to graph. We need to graph x plus y is less than or equal to 50, is greater than or equal to 20, this 6x plus 10y1, the 1/3 y1, and the 6x plus 7y is less than or equal to 350. These look like really big numbers, but when we divide it by 10, when we divide it by 7.5, they're going to get smaller. Okay, and we could do all this by hand, but like I said, Desmos does it for us, and I actually did go and type it in Desmos. It took me not long. I do have to clear this away though, so you can see my graph. So I'm going to do that now. Okay, and the graph that you get when you go into Desmos looks like this. Okay, if you go into your ebook and click on it, you'll see this, and then you'll see the inequalities on the left. Take a minute here to go ahead and sketch this, because I do want this in your book. I mean, in your notes that you're going to turn in today. You are going to turn in today's notes for 10 points credit. I was debating whether to make it 5 or 10 because they're kind of small. Okay, so yeah, so just copy this. This starts at, and I should have made it higher up there, 50, 60. So it looks like it goes through 0, 70 up there. I'm going by tens right here, all the way up to 70. And then it goes to, oh, sorry. I hate when my thing does that. And this goes to 100. Well, we only need to go to 70 here. 70 to the top, 70. So you need to make a big square. 10, 20, 30, 40, 50, 60, 70. 10, 20, 30, 40, 50, 60, 70. And actually, I have the important points on another screen. So, but I forgot to put this line in it on the other screen when I graphed it on Desmos. But here it is, because you need the important points. So sorry, it's a different color too, but that's okay. So, so that other line is y equals 1/3 x, and I'll try and put it in here. But here are the other ones. 0, 20, actually we don't end up using that one, but you can put it there. That's where the first line goes through 0, 20 and 16, 4. Okay, so go ahead and draw that in. There's another line that goes through, oh gosh, I did not mean to move that. Okay, there's another line that goes through 0, 39.6, so close to 0, 40. You could just put it at 0, 40, that's fine. But it says 0, 39.6, so you can write that coordinate there. And that line also goes through 26, 24 is what this says, 26, 24. So you want to make a line going through those 2 points. And that's a different color than all the other ones. If you have different colors, that'd be awesome. And then the other line here goes through 44, 4. And I don't know what point this is, but I don't know. Can somebody kind of see what point that is? My graph is really dark. Let's see if I can move this up a little bit or move my page down so we can see that. There's the coordinates. This, it looks like 20, 25, 26. Like 29, 19. I'm just going to say 29, 19. I'm going to write that down so you can graph this. Okay, this point looks like 29, 19, just somewhere close to there, just so that you get this line. You get this point and that point to make your line there. We're not even going to use that point though, because it's outside the shaded area. But this one is 26, 24. That's an important one. The other line is 1, 1/3. So that gives me 1133. If I could go through there, 1133. Wait, where is 0, 20? Okay, so 0, 10. 15, 5, 10, 15, 20, 0, 20 is right here. Okay, so other points that I need are 1133. So 1133 is, I'm just gonna say it's like right here, somewhere around here. 1133. And then another point on that line I need is 515. So here's 5 and 15 is right there. Okay, so let me use my drawing tool, my straight line drawing tool, which is handy. Okay, this point is off. I need to move it. It should go like that. So 1133 should be somewhere around, I'm gonna put it right here. I think it's right there, yeah. Not there. Okay, so that's 1133. So that's the line I forgot. So our important points, where are our important points? Where is the intersection of all this graphing? This is the line y is equal to 4 or greater than or equal to 4 is this green line right here. So we have like this region right here, this to here, and then this down here, and then this down here, and then this here. Okay, so I don't know, is that a trapeze? Is that a pentagon or a hexagon? How many sides? 1, 2, 3, 4, 5, 6. It's actually a hexagon, right? So the shape is a hexagon. That means we're going to have 6 points that we have to test. Okay, we have to plug all these points in. What are our critical points? We call these critical points. Our critical points that we're going to plug in are 515. So, you know, we should write that down somewhere. 10. I'm just going to be quick about this. So we're going to do 515. We're going to plug in 1133. We're going to plug in 2624. Oh, I forgot 410, 4010. We're going to plug in 2919 and 4010. Okay, our function, our objective function was number of tickets. I need to change colors here. Oops. Number of tickets is equal to 12x plus 10y. Okay, so let's plug in some of the points. I'm going to plug in 1133. Okay, so and always show your work at 1133. I'm going to plug in t is going to equal 12 times 11 plus 10 times 33. I didn't do this ahead of time. I should have. I got my calculator here. Hopefully you have your calculator. Somebody double check my work. $462, right? You get 462 for that one. So that's a big number. That might be our max. We're looking for the maximum, right? So let's plug in another point. Let's plug in 2624. So ticket sales are going to be 12 times 26 plus 10 times 24. Try this in your calculator. 12 times 26 plus 10 times 24. It's 552. It's getting bigger. So this one produced a bigger number. Okay, let's try. I would try this one next. I'm going to try 4010. And I'm going to skip through some of them for time's sake. I want to get started on that practice test soon. So ticket sales, T equals 12 times 40 plus 10 times 10. It's nice that these are in standard form. It makes it easy to plug in. 580. Okay, I was hoping that would happen. I should get a bigger number for this one. This one gives me 580. And if I plug in the other ones, 29, 19, 44, 4, 16, 4, and 15, 5, 515, they all should be lower than 580. This one ends up being the most. So this is my maximum. You know, if I were to finish this problem, I would plug in all the other ones just to make sure, but for time's sake, I'm not going to plug those in. I know that this is the maximum because I did it ahead of time. So this is our maximum number of monsters, right? What is the combination that produces the maximum number of monsters? This is green, right? This one is green. This one's yellow. So is 40 green monsters, 40 green, and 10 yellow monsters. Okay, so you always want to answer the question in a complete sentence at the end. So the maximum number of monsters that produces, the combination that produces the maximum number of monsters is 40 green monsters and 10 yellow monsters. All right, so that is the answer we found for number 99. And so this is yet another example of a linear programming. So I hope that helps you. I'm going to give you some more problems. There's the worksheet for today, the Valentine's worksheet. It's going to be Valentine's this month. It's February 2nd. Can you believe it, guys? Happy early Valentine's. It's way early, but Valentine's is the 14th. So you're going to do that Valentine's worksheet and a few problems from the book I'll post in a second, okay? But now is the fun time. We get to start the practice test. So take a little stretch break while I show you where the practice, stand up, stretch, get your blood flowing, jump around a little bit. I am going to, I don't think I ever turned off my camera. Okay, I need to clear this writing. So I'm going to do that. And then we're going to go to the, no, I didn't stop my camera. I meant to. We're going to go to the Google Classroom here so you can see the practice test. So when you click on, it should have posted. It wasn't posted until just like a few seconds ago. So has it posted for you guys? It says right here under, right above A10 classwork, it says A10 Chapter 3 practice test. Okay, click on that. And you're gonna, it's a Google form. It's 12 questions. Here's the deal, guys. I have to turn these around quickly. So here's the deal. I'm only going to make this worth 10 homework points, not test points. Usually we make them 10 test points, but I don't have a lot of time to turn around and grade these and get them back to you quickly. So what I'm going to do is everybody's going to get 10 homework points. If you complete it, you get 10 homework points. And I'm going to have to return it to you quickly. So it's not going to be corrected when I return it to you, but you're going to see the answers and you're going to correct it yourself, right? You're going to make your own corrections by just checking your work basically, and so that you practice for the test. So hold on a second, let me stop this.